Let's see. Hello and welcome to all my combo lords. Sorry it took a moment to get that going. Me, Demotro, and Dandelion are here chilling in my room because it's dark out where I'm at, 7:30 p.m., where it just gets dark. Actually it gets dark kind of earlier here some seasons. Luckily we're not on that bend of the curve. And today's topics will include Valentine's Day, including my thoughts on that, and maybe graphing some heart-like shapes and seeing the math behind that, and a story about how I made a big life change today, and kind of, you could say, quit my day job, but I'll give you the more detailed version of that in a story. And we will also be looking at some fun stuff about prime numbers. One of the ones I wanted to make a video about anyway begins in 214, and that's today's date. Well, in some ways of writing it, 214. Some places would write that 14-2. I do understand the logic there, but where I'm from, the month goes first. So I'm not the one who did it. Now, what we're going to start with today is some of the story stuff. And so if you want the pure math, that will be in a little bit later in the stream, time-stamped. After the fact, time-stamped. But first, what I want to begin with is a story about today. So basically, if you flash back 6 years or so, I was working at a music shop. And if you flash back about 3 years ago, we were in a very dark phase of part of what I consider grade 0 that you'll have to learn about in the future. I have footage and documents to show you in the future about that. But during that time, I was a music teacher after working retail in this shop, and on the side, I was making crazy videos for other YouTube channels you guys probably don't know about. Some of my Patreon people might know about it. And I'll share it with the rest of you at some point, and I'll need to incorporate the flashback footage anyway. But I was sort of doing a split-up version of current Combo Lord stuff. Right now, I sort of have this chaotic teaching video thing, Combo Class. And when Combo Class actually started as itself was pretty recently in terms of release, I had the idea and the name for a while, because I've always liked the word combo, and it's been part of my squad's vocabulary. And I have my own meaning to combo theory, which I'll explain more about later. And class, because we're in class. And it turns out that combo class also is commonly used to mean grades that have multiple grades in the same teacher. And that works because a bunch of you are different ages, but unintentional thing there. So combo class became a merger of those things, but I was still teaching because I needed to have any money for a day job. Now, I live at home with my parents and my brother, so, you know, I don't have crazy rent or anything, but I still needed a job, particularly to fund combo class, because it takes money to hire camera people and editors, and even buying used clocks adds up and stuff like that. And so at this point, I'm not making enough money from combo class to actually be earning money because I spend more on it still than I make, but it's on a right trajectory of me starting to make a little money from it. And so it was time for me to make a transition for grade -2. Grade -2, I had to have more focus for combo class. I had to have more stream days lined up at particular schedules. I had to have more guarantee I could make shorts and live streams and main channel content, and work on my books that I want to show you guys, and release my music and all that stuff. And so today I told my remaining students that I'm basically quitting. I'm done doing my private lessons. I may do occasional ones with them because I've grown a bond with my students, and I am teaching them the rest of this month, and I may keep in touch with some of them. You know, some of them got emotional when I told them I had to quit because they've known me so well. But it was time. And it's a risky maneuver. It's assuming combo class continues to grow. But, you know, I released the first footage for combo class less than a year ago. So we're on such a good trajectory that I need to dedicate my time to that. Additionally, a whole factor I didn't mention is that I got 2 surgeries last year, and I need to spend more time on my physical therapy. So, basically, starting in March, I am not going to have many or any private students. And I am going to spend March filming the last episode or two of Grade -1 that haven't been filmed in February. And mostly that will be the long documentary-like finale. And I'll be resetting the classroom for a special Grade -2. And Grade -2 will probably be coming on April Fool's Day, the 1st of April, or sometime slightly after that, if not right then. And March will be a month of reset that you'll see parts of, and some parts will be kept secret, because then April will be the month of seeing the reset. The modular clock resetting. Some things, of course, will be the same, like the dice and the floor, and you'll see what else has to stay the same and what has to change. But it'll be an exciting time. I'm going to have more days that I have my camera guy Carlo come over. Gonna have some other old people who I've worked with hired more frequently as well. Gonna work on making Grade -2 even cooler than Grade -1. Now, I'm going to take a quick peek at the comments, but yeah, that's exciting, risky, but we're going to try it out. We're going to see if Combo Class can keep getting an upward trajectory, particularly if I can put my full time and energy into it, which I will be able to coming March or April. Now, taking a peek at the comments before we jump forward, thanks to everyone who was waiting even before the stream. That's pretty cool. As for the thumbnail, we probably won't see all those things at the same time, but we will see all the things in the thumbnail over the course of this stream, possibly in pieces. And as to where I live, I'm in the Bay Area of California. And hello to the Combo Class bonus sequel. This is a younger fellow who originally named his channel after mine, and then I went down a rabbit hole because it was really weird of like, whoa, what's going on with this channel that's named Combo Class Bonus 2? And then the family made him change the name, but then I told the family I'm cool with it, and if him or the family's listening, I am cool with the fact that they put Combo Class Bonus Sequel back in the name. It's a funny part of history. I like it there. So, hello dude. How's it going, Combo Class Bonus the Sequel? I'm glad that you're into math. You seem clever for your age. And as to hitting some, that's an arbitrary number, but in our base, getting that digit will be nice while we're stuck in this base 10 system. I'm going to want that digit. Now, as for joining an online tutoring app, that's sort of against the idea of what I need. I have enough people who want lessons from me. I need to focus more time on Combo Class, even if it eats away at the rest of my small savings, and hopefully it'll work out. And as for Grade -I, Grade I will be something rare else. Someone said Patreon for new capture card ASAP, and I'm not sure exactly what that means by capture card. And someone said good luck. They hope the channel grows, and hopefully yes. Now, thank you all for joining me. What we're going to jump to next is heart curves. So, it's Valentine's Day. Holidays are weird, but we'll discuss, my feelings about Valentine's Day when we get the screen looking more interesting. And since it is a holiday, and, we can treat it playfully and have fun with it, mess around with some hearts on a graph. What would be a shape that would make a heart? Well, there's a mathematical shape named after a heart, and we can make that with polar coordinates easier than with other coordinates. Now, actually, maybe we want this to be a cosine. Something like that. Something like this is the shape called a cardioid, named after a heart. Whatever is that word root. So the cardioid also shows up if I have two circular things, like where's some coins at? If I have two circular things and I have a dot I'm tracing on the edge of this one, and I roll it around the other, like with my coin rotation paradox, but I'm tracing one steady point on the rolling one. If you imagine a little circle in there and a fella rolling around it, that's what you get in a continuous way. And funny side fact, when I made a video about why is the half turn rotation make a whole turn on one of them and a half on the other, or two on one and one on the other. It's a funny example of how a lot of people, it's almost like that dumb bell curve meme where the smartest or the dumbest agree or something. There's a lot of people who think that it's simple, but not because they know all the proofs and they think it fits into the algebraic system in too simple of a way, but because they've underthought it. And there's plenty of people who are like, when you put up a video that has paradox in the name, plenty of people want to be like, that's not a paradox just because da 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 da. But what their way of trying to get out of it is just by saying it's not a thing. And it's like, well, what if we want to consider it a thing to play around with that logical idea? Or consider maybe people who think the coin rotation is like, a lot of comments were like, well, duh, it's pi. That's not a paradox. Or like, well, duh, it's not actually doubled. Or like, well, duh, some random thing that's like, well, you didn't actually think through the reason, so you think that it's too simple of a question. So, interesting how things are usually really perplexing or interestingly paradoxical when you don't know too much about them, but also when you don't know too little about them. Now, Dandelion, do you want to go out? What do you need, Dandasaur? Want to go out? Nah, he's just chilling and bored. I'll open the window a little more in case he wants to go out this way. He did. So, this is a cardioid. We can also mess with it with this A. But how do we get a more heart-like shape? This thing will show up in future episodes. This thing is more important than the heart-like shapes we're going to generate. It's very simple and very interesting. But we even found it lurking in a lot of the crazier patterns that we made. Like when we're like, oh, look at these crazy things. Sometimes it was lurking in one of those. But let's say we want to make a heart. Well, there's things called heart curves. So here's some heart curves. Some of these are a little complicated, so we're going to go for the simpler heart curve right here. So we want x squared plus y squared minus 1 cubed. And what else was in there? Minus x squared y squared equals 0. X squared y cubed equals 0. And we got a heart. And what if we say it's less than 0 or equal? So sometimes in this stream, I will say less than for the less than or equal to symbol. So just to shorten a symbol, but it looks almost the same, but we don't want to see the dotted edge. It looks nicer that way. So technically less than or equal. There's a nice little heart. Now, what if we wanted to mess around with it? Well, what are some ways we could mess around with it? I could put A there. Look, I got different hearts and then they glitch out at some point. Oop. Now, what if I stick A somewhere else? What if I put the A in front of these ones? Similar but crazier glitch. Now, what if I, and I'll make this small so we can see a little more of the graph. Now, what if we mess with these? What about fourth power? Whoops. Fifth power. Uh-oh. Okay. Now, what if we put something here? What if instead of squaring this fella, we want to mutate this heart? Let's make this less than or equal. We'll come back to that fella in a minute. But what if I stick some A's in there now that we're adding A's? This is changing it, but not quite exactly that cardioidish. What if I stick it in there? Now, we're going to put A to be an integer scale right now, so that it only moves at integers for a minute. Now, let's see what happens when I make A 2. I have 2 petals. Let's see if that was both of these traits. No, I don't even need that in front. I just need it in front of the theta. 1 petal. 2, 3 petals when it's at 3. Do you see this? A is going to 4. 4 petals. 5, 6, 7, 8, 9. But when we go down to 1 petal, it looks a little more mutated. It's cardioid. How about -1? Get another same thing. Zero doesn't work. These ones work. That's pretty cool. Now we can't make it these in-between ones, like a non-integer thing, and have it look that neat, but we can try and see it for fun, these glitchier shapes. When I set the step smaller, look at all these. Wowie zowie. That's wild. These are crazy. And then when you hit an integer, it simplifies to that amount of spirals. So it's like craziness and then 4. Craziness and then 5. Craziness and then 6. Pretty wild, huh? So, let's go back to one of these hearts and we'll mess around with the heart. Ooh, A is all the way up there. We need to mutate these back into A. Not going to be a heart yet. Why isn't it being a heart? Did I change something about it? I removed the cubed by accident. Okay. What if that was the A? Those are weird shapes. Okay. So, Valentine's Day anyway. Weird holiday. I don't have anything to do because I don't have a girlfriend or anything. But still nice to celebrate love if you don't let the corporate aspect get in the way. The buying flowers and chocolates bit is a little weirder, but, you know, nice to celebrate love if you have somebody like that, or just in general. I do love all my combo lords. Not necessarily in a romantic way, but in my combo lord love way. So, you know, play along with the holidays. Why not have some fun with the silly ones? Now, someone's mentioning how the Mandelbrot set has a cardioid, and it's true. I cannot graph the Mandelbrot set right here. That requires complex numbers, but it will be graphed at some point in the future. And someone even commented the area of the heart. Awesome fact. I like those extra facts going in the comments. And thank you all for the other ones. So, let's play around with a few more equations because there's a few more things we could try here. And the first thing we're going to do is set A to different stuff. Let's go to just integers again, though, because sometimes those have neater properties. Ooh, look at these blobs I'm getting. Whoa, what's up there? Ooh. These are interesting. All right. Ooh, get a little like ice cream cone kind of. Ooh, these are interesting. Okay. Now, let's take a brief tangent from the cool looking shapes to note something interesting about graphs I found. This is pretty cool. So, we'll leave a heart on one of these just in case we want to be all Valentine's Day-y later. For now, though, what I got to show you is, let's say I want to graph one that we've done before. Well, let's go a few in a row. One that showed up in my latest episode on my main channel that you all should make sure to watch after this stream if you haven't yet. It's linked in this description, so get that ready for after the stream if you haven't seen it. We graphed, and this is only spoiling like a minute from it, don't worry. We graphed xy equals x plus y. Now, at first when you look at this, you're like, all right, cool, great. What's the big deal? I've seen shapes like this before. But what does this mean? This means sets of coordinates, x and y, sets of numbers, whose product are equal to their sum. We can see 2 plus 2 equals 2 times 2 is on there. Is a 1. It always works. Otherwise, they go there. And you know what? That meeting point looks suspiciously like E. Look at that. That's suspiciously like where E is at. So, you know, E pops up in a lot of these, such as one that we tried before, which was x to the y equals y to the x. Although I don't know if we thought of it in terms of what does the graph tell us, which is which sets of numbers is 1 to the power of the other to the power of that. And you get a line when the numbers are the same. It's pretty trivial on here. And you get a curvy thing where other ones work. Like 5 to the power of approximately 1.8 is the same as 1.8-ish to the power of 5. Pretty neat. And they cross somewhere. You know where that crossing point is? E. You guys know the number E that pops up everywhere? E. That's where they cross. Someone says they hope I plan to save this, and I always do, and I've been trying to add timestamps not long after they post of different parts. But for extra crazy fans who are awesome and want to watch the whole thing, then it will always be posted, unless something weird goes wrong. So, the number E shows up all over, and someone's correct. It stands for Euler's number, or Euler's constant, because Euler's number is, which one's which? Euler's number is E. Yeah, I always get mixed up because people call this Euler-Mascheroni thing, I don't know how to pronounce this part, but Euler-Mascheroni constant is what you should call this thing, so we understand what you mean. Some people call this other one Euler's constant. So I always get mixed up on which one they're calling Euler's number or Euler's constant. This one gets the gamma symbol, though. And we haven't really described what's going on here yet, but well, this one will show up. It does show up a surprising amount of places. You know how pi and E show up all over? This doesn't do it quite as much as that, but it pops up some surprising places. So, looking back at all of our E's, here's one that won't necessarily involve E, but let's zoom out and say, what if I wanted to know something new? This is one I just tried either today or yesterday. It was, what if we had x to the power of x equals y to the power of y? And I kind of wasn't sure at first whether there would be any non-trivial solutions. There's going to be a line where they're equal, where it works. But are there going to be any non-trivial solutions? And when you graph it, it looks kind of like a line that they gave up on at some point because they couldn't calculate all the solutions past where that line ends. But as you go in on the line, You're like, okay, all boring. Wait a minute. What's this? And then you go in and you see that, wait a minute, there is an extra bit. There's a non-trivial bit. And look, between 1 and 1, there's this little spirally guy, this little curve of other solutions where something like 0.8 to the power of 0.8 equals 0.2 to the power of 0.2, or something around that, approximately on here. So that's pretty neat. We can also think of it as an inequality and think, what if I stick that in there? Let's say when is x to the x more or equal to y to the y? Well, you get this whole region and then a little flip, but a curvy flip. So that's pretty cool. And as for if it's a circular arc, I don't know. It sure looks somewhat like it could make a circle in this 2 region, but it looks a little sharper than that maybe. Let's try and graph a circle there and find out. So if we put a circle somewhere, we'll start with a circle there with radius 1, but maybe it's bigger. I don't know. If we have x squared plus y squared equals 1, and then in this x, I'm going to put like x minus 1 to move it, and then I'm going to put y minus 1 actually. Oops. Uh-oh. Squared to move it. And it's not that circle. We'll give one more chance to the circle. Oh no! Okay, they have Command Z here. That's awesome. It's not that circle either. I don't think it's a circle, but I don't know. It looked kind of like it. So, thank you all for the comments. And what we're going to jump into now is we'll put our heart back on because it is Valentine's Day. And, you know, even if you are single like me, we can still be like, all right, cool, appreciate some love, apart from the corporate part. And what we're going to look at next, though, actually, is jumping back into math. And what it's going to be is looking at some prime number stuff that I wanted to mention in some stream anyway at some point. And I noticed that one of the main star primes that I wanted to tell a little story about begins in 214, quite similar to today's date, how it's written many places. So, let's first wonder, what does it mean to be the largest prime? Well, we must mean largest known prime. Oh, and by the way, let me put that cool shape in the background. That it was 2 equations that made the thumbnail one, but let's put it in the background for fun. It was the sine of x squared plus sine of y squared equals 0, I think. And maybe I did less than or equal to or something. Yeah. And then we're going to color it blue. And now it's a blue version of the thumbnail. So that'll look cool for the background. Now they are having trouble interpreting these parts. Sometimes when you like shake it around a little bit, it gets better, or you got to just zoom to a scale that it likes. Or you just deal with the trippiness. Does look like you're falling down a vortex. So, in any case, here's our Valentine's heart vortex. And what does it mean to be a large prime number? Well, it means a large known prime number that we've proven its primality, meaning that we have tested all of its factors or used factor testing combined with other methods and proofs to prove that it has no factors bigger than or apart from 1 in itself. And really, if you've checked all the factors up to a number's square, if you checked all the primes up to a number's square root, then you're good. Like if I want to know if any number in the up to 100 is prime, I only need to test divisibility for 2, 3, 5, 7, and 11. That actually gets me good up through 120. And that's because factors have to be paired up. And they're going to have one equal to or smaller than their square root. So, there are faster ways, though. And it turns out one of the ways, the ones that are easier to check for primeness, with some proofs they know about them, are a special type of prime I went into in my episode called hyper-11s. Hyper-11s are what some call generalized rep units, or generalized monodigit. And hyper-11s are my nickname, because why not come up with new nicknames for fun? That's what they look like. They're numbers that are just composed of a string of ones like that. Now, when I say hyper-11, we're letting it be in different bases. So, what does this mean in different bases? Well, when you go down to binary, there's only 2 digits, zeros and ones. So, this is a subset of the numbers that uses that one of the 2 digits. In fact, it showed up in my palindromic numbers episode, which was 2 episodes ago on the main channel, but you should also see. So make sure to check out that Hyper-11s and Pandigital later. And on the main channel, the main combo class, this one I'm actually going to rename to Demotro from combo class, because this is basically the Demotro channel, but it's basically combo class, same thing. My playground, though, instead of my show. And so here we got all of our ones, and in binary, this would mean 2 interesting ways of describing this. One is that it's using one of each of the spots that are a power of 2 in that base. Like, let's make a smaller one, and this would be using a 1, which is 2 to the 0th power, 1, 2, 1, 4, 1, 8, because that's what the places are in binary, and 1, 16. And if you add those up, that turns out to be 31. What was in normal 3-evens and throds? So, pure 3-even means it is a 3-even and none of the other vins. It is not even 5-even or feven or whatever. Seven, none of those, except 3-even. That would be a power of 3, another way of describing it. So the ones that are only even and none of the further vins are powers of 2. And these are numbers that are 1 less than that. And they're known as mersenne numbers after the mathematician Mersenne. The ones that are primes are known as mersenne primes. And they include the biggest primes we've ever found. So the biggest primes we've found could be described as the sum of a bunch of powers of 2. Could be described as they are 1 less than a power of 2. In fact, that's usually how they're written. This prime, 31, might be written on a list like 2 to the 5 minus 1. Because they might fit it in with a list of bigger ones by just changing that exponent. However, the coolest way to think about them is that they are a hyper-11 in binary. So, they're a hyper-11 in binary. They're also the ones of these not requiring it to be prime, but just the strings of ones, the hyper-11s in binary, are also, along with 0, the only palindromic numbers in binary, like I went into in that episode. I mean, the only non-palindromic numbers. Everything else has both the 0 and the 1. So, that's interesting that gives us such big primes, and there's an interesting history behind them. Not just the primes we have currently discovered, but you know how I was talking about E, and we got to talking about Euler? Well, you know how we've mentioned before that Euler, who is a god among mathematicians and the greatest yet, probably. Well, there's a whole article about list of things named after Euler. Because that's like a sub-article in this Euler article somewhere. There's a whole list of things. Where's that? It's funny. List of things named after Euler. They say also a lot of things are named after the person after him because he invented too much stuff. They ran out of stuff to put after his name. Look at all these things that were named after Euler. All these things with their own article. Holy moly. So, Euler is a god, and once again he comes up. There was a period where the largest prime known to humanity was discovered by Euler, and it remained the largest prime discovered by humanity for like 90 years about. even longer, maybe until or maybe 90 years till it's proven, and like 70 or 80 years till it's discovered. We have that somewhere here. In the history of the largest primes, they don't start with primes smaller than 8,191, because who knows who was first to prove that like 101 is prime. A lot of people probably. So this is the first one that they're like, this is big enough to give a record to someone. We didn't see any other documents. No, actually, no, it's a Discoverer Anonymous. Never mind. So here's one. The M17 means 2 to the power of 17 minus 1. It also means 17 ones when written in binary. And this is how it's written in our base. And here they're like, how many digits? And at first you're like, why do they need to say that? I can just read the number. Well, these things get big pretty quick. The largest currently discovered is 24,862,048 digits when written in base 10, or 82,589,933 ones with no zeros in the mix when written in binary. Hyper 11s, all these ones that say mersenne are the Hyper 11s. Look at all those awards they won. This prof type got up on the list, but dang, the mersennes were dominating. So, like here in the US, everyone makes a big deal out about the Super Bowl that just happened. I don't care about that. I care about when they find another of these. Now let's make predictions. Leave your prediction in the chat. When the next largest prime, it has to top the list, when the next largest prime will be discovered. The latest was pretty recent in 2018, but there's been a lot of discovery. I think it will be pretty soon. My guess is that it's going to be, pick a month and a year. My guess is that it's going to be in, I'm making an optimistic guess that it'll be November of 2024. So, here we got the current ones discovered, but what about back in the day? Here's a weirder form one. Most of them are in the form of a mersenne number, which they just write M then the thing, meaning 2 to the power of that minus 1. So remember how we said that 31 was a string of 5 ones? So that's too small for them to credit to anyone, but 31 is a mersenne prime. It would say M5 if it was on the list. What about M31? Sometimes you get to go another level. So once in a while that works. What about M31? Here we go. Now, why does this one have an article written about it and the others don't? Well, check it out. This is the one I was talking about that Euler discovered. It also says that he may have discovered the one before. They don't have explicit notes of him proving it, but they have like enough of his notes that the experts claim to believe that he knew this one was this type of prime. So possibly Euler on that. Definitely Euler on this 2 billion and that, you know, which is kind of hard to test if that's a prime. You know, if you're testing up to the square root and test all the primes up to there, got to test all the primes up to like 100,000 or more. So, like, for all you know, like 200,001 times 1, 2, 3, 4, 5, 6 multiplies to this or something. So you got to check a lot of stuff, but Euler, the beast. And so another reason this has an article about it, apart from the lengthy gap, which is part of it, look at this. So we got like, there was a big gap, but that one says anonymous anyway. This guy got 2. And we get a big gap. Then after Euler, we get, yeah, another gap. And then they start coming more frequently because of computer help. So this one, what led to this gap? And what story does it have? Well, look at this one. It's a ton of digits. And it took a computer to solve, I'm pretty sure. Well, this one, maybe the last one found by hand by someone. Because it says he used a special method where he only had to do 372 divisions, which would be a lot less than the up to the 100 or 1,000 or whatever. So after this, they may have solved the rest by computers, either after this or like the next one. Now it also shows up in places because 32 is a power of 2, and this is like 31 ones. It's one less. It's the sum of the first. They claim that when you have signed things, you get one less, sort of, to have the signed thing. We haven't gone into bit integers, but it's the largest value that a signed 32-bit integer field can hold. Now, here's an interesting one. I love this. So, it's a great story from history. I'm just going to read what they have here. At the time of its discovery, this number was the largest known prime number. In 1811, Peter Barlow, that's a mathematician and physicist, not anticipating future interest in perfect numbers, which are linked, they're these special numbers, they're divisors apart from themselves, add up to themselves, and yes, 6, our lucky number here, is the smallest of them, and they're super cool, and they're linked with the mersenne numbers, and the mersenne primes in particular. And so, not anticipating future interest in those, wrote, Euler ascertained that this is a prime number, and this is the greatest at present known to be such, and consequently the last of the above perfect numbers, which depends upon this, is the greatest perfect number known as present, and probably the greatest that will ever be discovered. Now, he didn't mean that he thought they were finite. He means because people wouldn't look hard enough, for as they are merely curious, without being useful, it is not likely that any person will attempt to find one beyond it. He repeated this prediction in another book. So, eventually we proved another was prime, of course. Now, maybe this was the next prime, one of these, the next one actually that was proven, and then the computer ones were not long after. But not quite that early, so a few more handmade ones. But that's a funny prediction to be so confident about. This is the largest prime that will ever be discovered. That's what this guy was saying. Because mathematicians won't have the effort, energy, or care to go. Now, prime numbers are not only curiosities, which he's using that as a diss, but what's merely curious is kind of a weird phrase. Like, curious is a holy thing. So, curiosity is good. Plus, primes also are fundamental to a lot of things. A lot of structures, if they have their composite elements described as combos of their prime elements. So if you know about primes, then you can describe the entirety of a lot of structures. So, that's kind of funny. Nowadays, we have primes with more digits than that. Is that true? Maybe not quite. Not quite. We have primes with 24 million, wait, let's see, this is, 2 billion, not quite. We have primes with almost that many digits. So, once again, Euler, the Lord. And hello to everybody, nice to talk to you. That's awesome to whoever has the garden. And thank you to who are people just saying hi and stuff. I'm doing all right. Rewatch the beginning of this stream later. Had some big life updates today, which will be good in the future. Have more time for combo class. For now, though, let's discuss some more random things, such as, what were some of the other topics that I wanted to cover? Well, let's look at a few of these mersenne primes. I want to go to what they have to say about these and see a little list of these. They have a connection with perfect numbers, which they have a whole separate article about. For folks who are curious, reading stuff like this is really good. Reading stuff like this, even if you don't understand all of it, I say you can trust Wikipedia enough of a medium amount to get a head start on knowledge and not quote it in any papers or anything, not be positive you know everything about the topic, but to get a good starting footing about a topic. They're actually really good with math stuff about not being very wrong compared to like biographies or stuff. Now, we just got to mention a few of these theorems that are crazy. I mentioned a few of these in my Hyper 11s episode. These might look like gibberish to some people, but let me put them in casual terms. This is saying that if there's a prime number that's 1 under a power, and you know, a perfect power is when we have some number to another power, and that's powers more than 1. Well, it's saying that if we ever have a prime under a perfect power, which outlaws that p equals 1 case, the only times a prime lives right under a perfect power, 1 less than it, is under a power of 2. You never have a prime 1 less than a power of 3, 1 less than a power of 4, 1 less than a power of 5. And what do you know? They prove it using modular arithmetic, something that's very clock-like and which I love. And I do have one of my clocks here. This is a clock of unity. This one's inside because it would easily get destroyed by the rain. I made it with paper-like things. Now here's another crazy one. Not only are the only primes that are under a perfect power right under a power of 2 in specific, but they're under a power of 2 that's a prime power of 2. 2 to the power of a smaller prime. So, like, if 31 was prime, which it was 2 to the power of 5 minus 1. Well, what do you know? 5 up there is also prime. Guaranteed. All those massive ones are 2 to the power of a smaller prime minus 1. And they're the only type of prime that can live under any perfect power. Absolutely wild. Hyper 11s have control again. Stay tuned in grade -2 for Hyper 11s, 3-vens, factorials, triangular numbers, and the whole gang to keep returning. Not even whether I choose to or not, they pop into topics. So, love you all for joining me. Let's see this heart of how much I love you. Oh, there's a cardioid being drawn. Check it out. This is what I was saying about a circle tracing another. And I love you all, not only in the cardioid way, but in the more typical heart-y way. You guys are awesome. Maybe someday I will have a combo girlfriend to also give a heart to. For now, having an insane amount of fans and viewers is pretty cool, and I'm going to roll with that. Even though life is intense and hard, and I got 2 surgeries, and I only just now quit my day job, you know, there's good things about life. So, someone's wondering, does this mean there's no need to hunt for primes because we can go 2 to the p to the q? And no, it does not always go that way. 5 gives us 31, but it's a one-directional proof. It does not mean that if p is prime up there, then the result is prime. It's just the other direction. If that's prime, then the p was prime. There will also be other ones that aren't. But super cool. And yeah, someone explained it well by saying it's not bidirectional, you know, that it only is going one way. They also have some other wild proofs about these things, and here's a list of them. So, these are some mersenne. No, these are exponents. This is interesting, yeah. This is the list of the little p's that make the big ones. Like, 2 to the 2 minus 1 is 3. That's our first mersenne prime. 2 to the 3 minus 1 gives us 7. That's our next. 2 to the 5 minus 1 gave us 31. 31 is on there too because that was the little exponent on the one Euler found. Now, we can also see that that was the little p's. Where's the big p's? Oh, this is good. They have an awesome table. Look, we have the mersenne number paired up with the perfect number. As I showed in an episode, there's a 1-to-1 correlation. And all this stuff they want to say I showed in an episode, remember, main channel. And there's also a newish episode there that's super cool that relates to this, is part of why I thought of that. Oh, no. So 6 is perfect because of this, but also those. So it's perfect because those multiply to it or add to it, and they're its only divisors. But what about other things like 2 plus 2 equals 2 times 2 being compared to 1 plus 2 plus 3 equals 1 times 2 times 3? So here we got perfect numbers that have that trait where they're proper divisors, they're factors apart from themselves, add to themselves. We are also going to give a bonus definition for them now in anticipation of another episode coming soon. Sometimes we want to talk about their whole divisor sum to be using a general trait of that compared to other things. Their whole divisor sum would be that plus themselves. So it's equivalent to say that all of their divisors, counting themselves, add up to twice them, because you get another of them in the mix. So we can either define perfect numbers as their factors apart from themselves add to them, or all their factors add to twice them. That will be important when we look more at multi-perfect numbers, where the factors apart from something the factors apart from something. No, the factors including it, okay, I'm getting confused on the terminology here. The factors of the multi-perfect number, including itself, add up to another integer, like how this adds up to 2 in the case of a perfect number. 2 times it. Or you could divide it by it and get something called the abundancy index that will be in a future episode. So stay tuned for abundancy indexes later. For now, let's just see how they note that there is a possibility we might find an odd perfect number which wouldn't have a one-to-one correlation. An odd perfect number would not give us a mersenne prime. However, it's conjectured there's not an odd perfect number, but it's not proven yet. So even perfect numbers, we have to clarify, which are all the ones known, are perfect if and only if there's 2 to the p minus 1. They are basically 2 to the p minus 1 times 2 to the p minus 1, where that thing in the parentheses is a mersenne prime. So if you ever have a mersenne prime, 2 to the p minus 1, and you multiply it by this lookalike, 2 to the p minus 1, all up there. Let's get closer on that. Here you got normal. This is a mersenne number, and if it's a mersenne prime, we can multiply it by this lookalike phrase using the same little p there, but with the 1 up there, same little p, and get one of the perfect numbers. So look, mersenne prime 3, its perfect number that's its friend is 6. 7 goes with 28. 31 goes with 496. 127 goes with 8,128. And to anyone who hasn't appreciated these numbers before, all of these numbers in these first columns, the ones in the first 4 rows at least, first 4 rows, epic numbers. Look at these, 1 through 4, first 4 primes. These are underrated numbers. Perfects and mersennes. Very underrated. They often have other cool traits. Every perfect number is also a triangular number. That's the sum of the first 3 numbers. That's the sum of the first 7 numbers. That's the sum of the first some amount of numbers. Oh, is it 31 numbers? Probably, yeah. Probably some of the first 31 numbers. I believe that pattern holds. So to double check, 31st triangular number. Why do I have caps lock on? Okay, yeah, 496. So yeah, it does link up that way. So it's always that triangular number. Super neat. These things have an infinite amount of connections, although we don't know if there's an infinite amount of them. And here's Euler's one right there. Da, 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 da. Pretty neat one. Gets its own article. Now, we'll get even more facts if we look at the articles for these. And since all of these in the zone I called underrated have articles about them, we are going to take a little stroll through some of them. We're going to look at the 2-digit numbers here that might be underrated to you guys. So what's going on with 20? And the reason we're not doing these is because they're too classic. 7's a little overrated, but it's still classic as a low prime. 3 and 6 are too godlike. So we're going to do those later so I don't do like a 4-hour divergent tangent on that. We're going to do 28 for now. 28 seems like a kind of dud of a number. 2 squared times 7. It's kind of arbitrary. But what do you know? It's the sum of the first 7 numbers. It also has that connection, because of being a perfect number, with the mersenne prime 7, where if we take the mersenne prime 7 times 2 to the power of that little p minus 1, we get it. And some other facts about it. Whoa, look at all these types of things it is. Wowie zowie. A lot of types of number. And it has a unique trait of random things it can be the sums of. And if we get into physics, it happens to be the atomic mass of silicon and the atomic number of nickel. What do they mean the atomic mass is exactly 28? No, it's about 28. It's not exactly 28. I want to go into the periodic table sometime and look at all those weird elements that I think they're renaming or have renamed. They used to be called like unquadium. So a lot of the low numbers do have a lot of titles like that, but 28 has slightly more than some of the other numbers in the 20s. What about this other underrated fella? 31. So it's a prime. It's also what we can call a super prime. What that means is that it is the 11th prime and 11 is a prime. Can we take that further? Yeah, 11 is the 5th prime. 5 is a prime. 5 is the 3rd prime. 3 is a prime. So yeah, this is actually cool. So 2 is a prime. What's the 2nd prime? 3. What's the 3rd prime? 5. What's the 5th prime? 11. What's the 11th prime? 31. So, other lots of properties, and this is one of my favorites. Oh, well, there's 2 of my favorites. A lot of my favorites. So, whoa, too many favorites. So, 31 is such an underrated number. Let's go. 31 is, first of all, related to regular polygons and how many can be constructed, which we haven't gone into yet. It is a primorial prime, which I have hinted at, but I don't know if I've talked too much about these, maybe made a short about them, where they're primes that are 1 less or more than a primorial, which is multiplying all the primes together up to a point, like a factorial would multiply all the integers. And 30 is a primorial, because 2 times 3 times 5. 30 is a pretty great number. When I say 31's underrated and great, it's not better than 30. 30 is still a cooler number. The debate would be between 31 and 32. Those would have to get in a ring and fight, because like 31 and 32 are both A-grade numbers, and 30 is S tier. But on the big scale, they're all S tier, but you know what I mean. So 31 is a primorial prime with a twin prime. 29 and 31 are twin primes that are hanging out around a primorial. There's not that many of those they know. It's also all that mersenne stuff we talked about. It's also all these other shapes. Also graph theory stuff. Now, here's one I've talked about that's super awesome. It's a rep digit in base 5. That's what they're saying for my hyper 11s. It's hyper 11 in base 5 too. We said it was 5 ones in binary. It's also 3 ones in base 5. Now, what they're not saying here for some reason is that it's conjectured to be one of only 2 numbers with that property. And what do you know? This is the other. These 2 numbers are conjectured to be the only numbers that, well, to be clear, that are hyper 11 with 3 or more digits. because 2 digits is trivial. Every number is 2-digit ones in the base below it. So hyper 11s with 3 or more digits we'll call, like in this case, the non-trivial ones. To be that in 2 bases is rare, and conjectured that these are the only 2 ever. 31 and 8,191. Why don't they have an article for that? Is it because they have an article earlier, or they have an article for all sorts of weird numbers? They really don't have one for that great number. What can you do? Somebody should find some facts about that and submit it. And I will be the one to submit the article about multiple of 3, also known as threeven, sometime in grade -2, because I'm compiling some legit facts so that they'll keep it up. So stay tuned. Sometime in grade -2, I'll let you know when I make a Wikipedia page full of facts. Hopefully they'll keep it up. That says it's called multiple of 3, and the first sentence is like multiples of 3, and then in parentheses, also known as threeven numbers. And we'll see if we can get that in. It's one step toward having it in the dictionary. If we get our Wikipedia page, if I write a book about it, and if a few journalists write about it, then we're good. So, what's cool about these other ones? Well, this one we already noted some stuff about. What about these bigger ones? So 127 is actually really cool. I like 127. So 127 is the mersenne prime related to the perfect number 8,128. Also, 2 to the power of 127 minus 1 is a prime. It's not only what you get as a mersenne prime, it's also one of the little p's. It's one of the little p's and the resulting bigger p's. Discovered by Edouard Lucas, who they often call them the Lucas numbers, but it's pronounced more like Lucas or something. But those are super cool. It's this variation on the Fibonacci numbers that actually has a lot of cool properties. We'll do those in an episode in the future. And some arbitrary facts here. And some cool facts here. And a lot of random facts. So 127 is pretty neat, but what about its friend, 8,128? They don't have that much about this. They got some cool ones, though. So, triangular numbers in general, along with other ones that are known as figurate numbers, or to be specific, polygonal numbers in this case, or we can make polyhedral numbers or stuff, will be the theme of several episodes in grade -2, including animations of them. I'm working with an animator dude. And they are super interesting topics. And, in fact, I wish I could show you. An animator made me this thing of tetrahedron of balls that we'll use. We also might try and build it in real life. 2024 is a tetrahedral number. So we're going to have to build a massive tetrahedron of something. But all those numbers have super unique connections and properties. And one of the awesome things about them is they include the square numbers and cube numbers. The square numbers we think of as x times x. Maybe you also think of some weirder things like they are the numbers with an odd number of divisors. Or they are the numbers that are the sum of the first n odd numbers. Or other ones. I might someday make a whole episode that's like 10 ways to define square numbers or something. Because there's a lot. But one of the ways we can define them is as a level of polygonal number. You can have triangular number, square number, hexagonal number, pentagonal in the middle. And there are definitions for how many numbers you define as how many balls make that shape. And the clear definitions result in simple formulas, but also ability to visualize them as shapes. And they are really neat. I like those polygonal numbers. Think you guys are going to like them too. So, taking a peek. Oh, I forgot the 31's the rule breaker thing. I forget if they mentioned that or not. But 31 breaks this cool pattern that circle division. We made a short about this already. And they have an article about it, I know. Look, I knew it as this, Moser's circle problem. But they're just going to have an article just called Dividing a Circle into Areas. When I saw that as a blue text as another one, I'm like, that's a funny name for a Wikipedia article. But they mean this specific problem
And it's a really cool one I went into in a short, where if you put 2 points on a circle, you're going to get 2 regions. 3 points, you're going to get 3 regions. 4 points, and let's say you want to maximize the regions going forward. So we're saying we're going to try and put it forward so there's the most amount of regions. If we put dots on the outside of a circle and connect them all with straight lines. Well, we get maximum is 1, 2, 4, 8, 16, 31. And the 31 is because of we're adding the first 5 numbers only related to this limit they get hit on of Pascal's triangle. So this will probably have a revenge in a full episode, like some of the shorts have a revenge showing up in the context of something else in a full episode when we do Pascal's triangle. Because here's the thing. The Pascal's triangle episodes are going to be the same episodes as the polygonal and figurate number episodes. Pascal's triangle not only is this cool plusy thing and the binomial coefficients, to anyone who knows about those, Pascal's triangle is also what I call the meta-triangular numbers. The triangular numbers, the tetrahedral numbers, the what you can call the something simplex numbers, the triangles of all the dimensions, and how many dots or balls or 4D balls it takes to make them. So Pascal's triangle, it's really connected to triangular numbers. They're a row in it, but also the meta-dimensional versions of them go upward. And when you go earlier from them, you get the natural numbers, making you think, square numbers are constructed from adding up all the odd numbers up to a point. Triangular numbers add up all the natural numbers up to a point. That sounds more full or more logical almost. Triangular numbers could almost be seen as more fundamental than square numbers. So they're one of the really underrated things that actually I didn't put as much into grade -1, but I've planned some really great episodes about them. And they're definitely one of those things that will show up all over the place in random topics. Is sometimes other figurate numbers like pentagonal numbers sneak places, but triangular and square numbers love to sneak their way into places. So thank you all for joining me. And oh, hey, thank you so much to whoever looks like left a donation. That is super nice. Thank you to the memes of destruction. All of that stuff deeply supports me going forward with, like I mentioned, I basically quit my day job with my private students so that I can have a steadier streaming schedule in March and have a better schedule of dropping all my content more frequently and make it even better. Because I want to take my time on some stuff, but I want it to come out a lot. Maybe I can give you the best of both worlds. Although to a degree, remember that this channel is more my quantity channel, and the main combo class channel is more my quality channel. Of course, you'll see quality on this channel, and hopefully you'll see quantity on that channel. But to a degree, that one's a little more my perfectionist, like get them exactly how I want them. And this one, we get a little rambling, we get a little fun real life slice, we get all the shorts and stuff, and this one's blown up way past the other one. Which is why I'm probably going to rename it, like I've said, to Demotro something, like Demotro from Combo Class. In any case, thank you to the memes of destruction. Grade -2, with all the little funds that people are sending in to help, and the Patreon supporters and such, is shaping up to be pretty awesome. I'll have like slightly better audio gear, slightly better cameras for my streams and stuff, and I'll be able to set, coming in March, probably at least 2 days a week that are fixed times when I'm streaming. One of which will be in the evening for me, which is around this time, and another day will be in the morning for me, like 10 hours before this, when other time zones can appreciate it. But I will make the streams try and be digestible as videos. Also, my awesome moderator on the Discord, which is a great place to chat with combo lords, my moderator, the Magic Fellow, might start helping me moderate some of those weekly streams, and then I can focus on some other stuff. He can, maybe send me key questions or something, and I can make sure I get my tech right. Maybe I'll also have someone on this end sometimes helping me with the tech side of things. Maybe I'll get another monitor so it's less chaos popping up on here. So, sorry if my face is cut off too, and I'm tiny, but let's take a brief break from all these circles. I'm going to make myself large and appreciate our dandelion, who's still here, being a sweet little soft boy, just sleeping and resting and waiting for love. So, to whoever asked if this is a math stream, there's kind of the topics I covered in the description. We've gone through most of the topics, so there's a graphing part you can jump back and find. And there's a talking about Euler part and talking about primes part. But there is now a little chatting section. And to whoever noted they would attend an in real life lecture, maybe I'll do some type of event at some point that could be fun. I don't know how many people are near the Bay Area. If anyone's near the Bay Area and would come to some sort of meetup or interesting live thing, keep me posted and I'll think about it. And someone's wondering if the hyper-11s are connected to the something-gonal numbers of polygonal numbers. Not that obviously. 31 got lucky in a few ways maybe, but they do have connections. So thank you all for joining me here. Oh, and yeah, to ask about math, I guess they're new here. Welcome. I am Demotro, and this is my cat Dandelion, and we like chaotic learning around here, and we're all nice and cool. So to all you joining me, I think I went through most of the comments, but thank you for leaving them as usual. And I don't have too much more planned for the rest of this stream. So for a moment, I'm going to reiterate some cool things that are coming that are just a little clearer of what I said last stream, which is that now that I'm cutting away from my students in March, I'm going to try and have all the main channel episodes that are coming before that filmed in March in February or very early March, and then have most of March to do a reset. My hair might look different sometime in March. I might have a new lab coat sometime in March. I might have a new desk. You might not see all of that until grade -2 premieres on April 1st or so. So there might be like a week or two where I'm streaming in my room and you don't get to see all the secret evolutions, but they will be documented for a crazy finale episode that will be coming out in mid-March that will just be about my wild experience making this grade, the culmination of a few symbols and things like that. Sort of on the vibe, more of a snack break than a pure learning topic, but an extended look into behind the scenes of the chaos of making a grade from the dirt while getting 2 surgeries and having just come out of almost dying from something else a year before and making some crazy stuff work. Grade -1 was just an experiment, but the experiment will continue. So, you're all awesome. Feel free to leave any more comments. We're going to get one more reminder that to anyone who wants to celebrate your Valentine's Day today, it is a common holiday, and I will have some appreciation for Dandelion, although I guess it's not the same romantic type of thing. It is still nice to just appreciate that there's some holiday trying to be about love, although originally it was called the Feast of St. Valentine, and it evolved a bit from the Feast of St. Valentine. Also, there are multiple people named St. Valentine, and it's ambiguous which one it was named after. But you know how holidays go. I think they should maybe cut out Valentine's Day and just call it Love Day or something, Heart Day. You know? Why does some dude need a name? And it has kind of bad connotations for some. Like, it makes some single people feel lonely. But, I mean, I don't feel any different today. Although, in general, I can be lonely. But Valentine's Day is a weird construction sometimes. But if you do have someone who you are Valentine's with, awesome. And I at least have my dandelion. So, someone wants the cat closer to the camera. He may come and say hi to the camera a little later. Right now he's flopping his belly, and I don't know if you can see, but he's totally flopping his belly. And he likes getting his belly rubbed more than anything. He has a technique, a 2-layer technique. Here's how the 2-layer technique goes. Let's make me and Dandasaur big again. The 2-layer technique works if he sees you coming, and it's within the 90% of the time where he wants pets. He will run in front of you, and then about 5 feet in front of you, he will skid out on the ground with his belly up and his arms wide spread. Like, I'm here, I have a stomach, I'm here. And if it doesn't work and you continue to walk, he will stretch as long as he can stretch. And he can get pretty long. And if the first technique doesn't work to get you to pet him, the second technique always works. He has figured out that going long makes something happen that people think is cute. Like, it's not like he knows genetically that long is cute, I don't think. But I think he found a correlation that when he went long, he gets more pets. And he's like, okay, I'll do this. The humans like when I go long. Because it's really cute. So, that's a dandelion technique. Pretty nifty if you're a cat. You know, if you need some more techniques. So, someone's wondering about the grades, and yeah, grade -1 is the era we are in, which can be mapped by the main channel, but also by all the shorts and live streams that occur during that time. And it is basically just a mix between a grade of a school, a season of a TV show with a bunch of behind the scenes, and an era. And to all of those who joined and commented in grade -1, you're going down in history, fellas. So, grade -2 is next. If I do a grade I or something, that'll be the name for some sort of memoir-ish, documentary-ish project, probably, because that fits. My birth name has 3 I's, and those actually multiply. 3 I's multiplied. And I'd be like, maybe I'm grade 13. Maybe a college calls something that. Maybe it'll sound like you can't watch it if you're younger than grade 12. No, we're going a new direction. We could go the imaginary axis, but that's kind of doing too much. It's already a new terrain to conquer. If anything, another one we'd try is fractional grades. But those could be, if I ever do, this is actually an interesting thought. Just combining 2 thoughts I had. One thought I had was, what about fractional grades, like 1/2, 1/3 and stuff? Another thought I've had was maybe someday of having a side channel of younger education, just like my way of presenting what is addition, what is negative numbers and stuff like that, just to like help the world, to teach my way to younger people that as just a side project. Maybe that would be a good combo. In any case, like calling that grade 1/2 and grade 1/3 and stuff. Those would be on something else, but there will be other random stuff on this channel. There will be music videos coming once in a while. Warning, because I like making music and I just haven't posted any Demotro music yet. I've had many musical projects in the past, but warning, once in a while there'll be a Demotro music video. Whether or not you like them, stay tuned. There'll still be all the other stuff in between. There will also be those. There will be just more frequent cool stuff. In some of the weekly streams, me and the Magic Fella, who I see is here in the chat, are setting up some puzzle-based thing where we may be able to have some sort of weekly puzzle for you guys to participate in. And some of that will be through the Discord. So I didn't use Discord before the combo class thing, but now I use it, and it's just because I like the combo class page. A lot of fun sub-channels on there of cool topics. So if you like chatting with people in the stream here, you'll like the Discord. So, someone's saying the reciprocal of the golden ratio grade. That would be true if we did fractional grades. We could also include irrational number grades in the mix. Now, it is a thought of, you know, when does certain irrational numbers happen? I would say we could think about it as, if we're a rolling clock, maybe we're at like grade -1.9 right now. So maybe we passed the golden ratio grade a little bit ago, or the negative golden ratio itself. Negative golden ratio grade. So what about -E? Grade -E will be sort of like an episode later in grade -2. Grade -pi That would be an episode early-ish in grade -3. You never know. But you never know. Grade -2 is going to be similar to grade -1. You never know what grade -3 or onward will hold. Could be similar. I could be on a jungle in an island somewhere. You never know. All right. And yep, a lot of links are in the description. So thank you all for joining me, even despite the random chatting. Some of the other plans coming forward are going to be of the 4 main channel episodes, which also go along with the shorts and other stuff I do. Like, another warning is I might make a short that's related to the last main channel episode I made. I just need to make a short of it because it's such a cool fact and puzzle. And sometimes it helps to make a trailer like bit of a main channel one on here too. So there will be one probably about that 1+2+3 thing as a short. But I'm also going to film a bunch more other shorts. And some of them often are related to the main channel episode, so I'll list those topics anyway. We're going to have that weird finale and 3 more other episodes. That's going to get us to the number 100 looking number in base 6, which is 6 squared, which is 36. So 6 is a glorious number, 36 inherits a lot of its traits and has a lot of cool traits of its own. 36 is probably the... Well, wow, there's a lot of cool numbers in the 30s. 30, 31, 32, 36. Those are all all-star numbers. So 30, I would even arguably say 31 and 32 are just like A+ tier, but 36 is S tier, which is above that for some reason in how tier lists are often written. The higher tier is 30 and 36. Those are epic. So now, just like, I gotta just show you real quick. How are a few ways we can make 36? You want to see a few ways we can make 36? Let's make Wolfram Alpha come up. Well, what if I wanted to wonder, what do I get if I multiply the first 2 primes and then I square all that? Well, okay, that gives me 36. Okay, first 2 primes multiplied, then squared gives me 36. What if I say first 3 numbers squared? Oh, that's also true. The third 3 factorial squared, we could say. So 3 factorial squared gives me 36, I mean. Oh, what else could we do? Well, it turns out I could say that not only is 1 + 2 + 3 squared equal to it, but also 1 cubed plus 2 cubed plus 3 cubed equals 36. Isn't that crazy? It's a link that triangular numbers have with cubes. And what if I just wanted to add some numbers? No squareds in the mix. We're just adding numbers. There you go. Okay, well, what if I wanted to add up a staircase and back down instead? Up through 6 and back down. There you go. That's just the start. 36 is epic. All-star number. Doubly even and doubly threeven. Awesomely good. Numbers that are just even, like I called them pure evens, can also be called too smooth, like this. And numbers that, not numbers that are just pure threevens are 3 smooth. That wouldn't work because 3 smooth means prime factors up to 3. So 36 is actually 3 smooth because 3 is its largest prime factor. So 36 has a lot of superpowers. How did I even get to this topic? Oh yeah, that's how many episodes are going to be in grade -1 on the main channel. Leaving 3 more apart from the finale. And those 3 are going to be on 1 is a language-based topic. And it is language math, though. It's related to numbers written down in English as an example, but we'll learn things about potentials of how you could write numbers in general. So it's going to be some fun facts and kind of paradoxical traits about writing down numbers in English. I also have a few shorts I'm going to put out, at that time that are old, that aren't on YouTube, that I filmed like a year ago. No, not none of this was filmed a year ago. This would be filmed May or so last year. So getting close to a year ago. But last like May or June, I filmed a few shorts about this topic, about taking letters and spelling them into weird traits. And some of them didn't get on YouTube because I knew I was going to make a whole episode about it. And I was like, I'm going to wait to put this on YouTube until I make the whole episode. So some of them will have shorter hair in. Don't get tricked. Read the description or comment. It'll say, I haven't cut my hair yet. This is old. But the actual episode will be filmed new. And it's going to be really fun. That's a sort of language math combo. And then there's one spot that I've left empty. I'm pretty sure I know what episode will go there, but it's good to leave something up to possibilities. What if lightning strikes the combo class and I need to make an episode about that? What if, there's just one fact that makes so much sense for me to do a given week because of some prop or whatever? I gotta leave one spot blank, just in case. I do have way too many ideas planned for it. All of my coolest ideas didn't fit into grade -1. So this might be one of those, which there's a decent chance it will be an episode about this cool paradoxical stuff about dice, including some personal discoveries. But I'm leaving it open to the wind for now in case lightning strikes the combo class. For the last non-finale episode, we will have an episode about infinite reciprocal series. Infinite series of numbers that some of them converge, some of them diverge. Which ones converge to... Here's some questions that will come up in there. Which series converge to a finite thing, even if there's an infinite amount of things in them? Which ones converge to interesting, cool numbers, like integers or classic constants? What's traits that make something diverge or not? Are there types of thing that we know which ones go to infinity or not always? What are some ones you'd think would go to infinity but don't, and vice versa? And how does this relate to a grade -2 episode I'm going to make explaining the Riemann zeta function and the $1 million Riemann hypothesis that you literally get $1 million if you solve? So there'll be a little hint at the end of how it connects to that future topic. Which, I'm not joking, there's an institute that will give you $1 million if you solve proving whether or not all of the zeros of the analytic continuation of the Riemann zeta function on the complex plane lie on either negative even integers or on the line x equals 1/2. You get $1 million. So that's a good episode, but first we got to lead up there with a cool and crazy enough episode that I want you guys to imagine going down a corridor halfway, or things like that. Adding half a grain of rice, getting half another. And we're going to make that last main non-finale episode about infinite reciprocal series pretty awesome. So those are coming. We're also going to have just random streams, random shorts and stuff. I want to try and get this channel to 100,000. So that's a fun little mini goal because I want to, just fun little extra digit. It'll help us out. And so let's try and help us get that extra digit, even though it sounds superficial and I'm embarrassed to say it. So, even though telling your friends about this channel, what's even more important is spreading the word threeven and telling your teachers to play these in class. So that is actually something I'm going to start someday. I'm going to get people to do this somehow. I'm going to say that once a year, since people who are in school, each year they go to a different grade. Once a year, I'm going to pick a day or week. It's not yet. You can do it now. You're totally welcome. But there's going to be a week where it's called Tell Your Teacher About Combo Class Day. Or Tell a Teacher About Combo Class Day. In case you're not going to school and you just know a teacher. We need combo class played in more schools. It will help the educational system. So there will be a day I'll elect sometime. Or if you just want to, just do it before the school year ends if you're in school. Or college, or a teacher or whatever. Tell a teacher about combo class year. Okay, no, I'll pick a month. I'll pick a week. So, Dandelion got a comment. I love. I have this funny. Dandelion's so funny to me. He's a creature that makes me laugh when I feel gloomy because he stretches in the silliest poses and he's simultaneously cute and just ridiculous. And he's just like this weird, fluffy delight. And so he makes me laugh when I feel gloomy because he's just so silly mixed with the cuteness. And I find it like almost as much as I'm excited about me getting like known online. I'm like practically equally excited that Dandelion is getting a little fan base because that's just so funny to me and cool to me. And I'm gonna make more. I'm gonna send more pictures of him to the Discord so we can make more emojis of him, which there already is one of a little picture of him. So oh yeah, whoever's mentioning the decimals that make the Fibonacci numbers, we will go into that in an episode for sure. Either grade -2 or maybe it'll end up in grade -3 because I have a lot of topics planned. But there will be an episode about that, about these really interesting decimals that generate what looks like the Fibonacci sequence and has genuine properties connecting it, like not a coincidence. So and someone mentioned that one of the constants, the zeta function, comes up in physics. You're super close, but we need a 3 in there. It's zeta of 3 is a Paris constant, or however you pronounce it, a Paris, or whatever it is. A Paris constant. Zeta of 3. Because zeta of 2, weirdly enough, is pi squared over 6. Pi squared over 6 is going to show up in this episode. That's actually one of the ones that links the reciprocal episode and the Riemann zeta one. The Riemann zeta function is about adding reciprocals. So it's a very natural follow-up to an episode describing, like, in the first one, we're just going to, after introducing some surreal concepts about them, and before going into some really paradoxical stuff, the middle of the episode is just going to have some really fun ones. There's just, like, some really crazy, like, what if you take this series? Like a type of series you know. What if we flip all of them into reciprocals and add them? Well, it converges to this number you know. So there's a lot of fun ones of those. So make sure you're all tuned into the main channel and you've seen that new episode. In any case, leave any more thoughts and comments. I gotta go. Not because I'm doing anything super Valentine's-y, unfortunately, but because I just taught one of my last days of teaching, and, you know, I did a long day of writing, teaching, working on combo class, and having fun chatting with you guys right here, along with the mathy stuff I fit in the stream. So, thank you all for joining me, but I will be logging this off pretty soon to get an awesome, because some people are like, well, what's important about that? Well, there's a lot of secret links, and it's good to have a link, even if just to show people, like, look, I told you the Riemann zeta function has real stuff about it, even when you're talking about this imaginary-like stuff. That's can be phrased on the real part of it, but still, that's some wild rabbit holes to go down. So in the meantime, if you want to think about those infinite series, you can think about, well, what's different about adding up 1 plus a half plus a third plus a fourth plus a fifth plus a sixth, and adding up 1 plus a half plus a fourth plus an eighth plus a 16th? What's different about those, and what's in between those? And thank you again to that Memes of Destruction who's saying bye, and thank you again to all of my viewers joining me. You're all my combo lords, and if you want to catch me again before whatever I do tomorrow or the next day, remember that I'll be checking the Discord when possible, as well as the subreddit, and definitely the Patreon. Also, if you want your name on a whiteboard in the finale, I'm doing that for Patreon people, or closer to the finale if you have either donated some type of money or just commented on a billion things over the years. Leave a comment being like, can I get on the finale whiteboard? Leave that on a later stream closer to then, if you aren't on the Patreon but really want your name on there. But for the Patreon people and a few fans, I will be putting a bunch of names on the whiteboard in the finale to thank people. Maybe I'll also get some cameos from the different people who helped me film the grade. I'll also get some cameos of these guys, because they kept me at least partially sane during the grade. And yeah, A lot of stuff to thank. We'll do a little thank you in the finale again to whatever aliens might be watching. And to all the cool nature around. All the birds. There's some cool birds in the combo classroom. I wish we could be there now, but I guess it's night, so they're sleeping anyway. So, all of you are great. I'm going to log off now, but catch you in the next one. I'll put some timestamps up in a little bit, so I'll update them as I go, so you can, refresh the page if you want to see some timestamps appear. If you're rewatching any of the earlier parts of this stream, where I talked about quitting my job, heart shapes, and primes. I'll catch you guys probably tomorrow. If not, it'll be the next day. I know I am filming tomorrow, and probably will try and get a short or two in addition to whatever long episode content I do with my guy Carlo. And catch y'all very soon. Have a marvelous day. And let's end with one last heart. I was going to do a heart, but we get a mathematical heart. The cardioid.